Right now, at this very moment, you're doing something your brain isn't designed to do. You're trying to understand a number so large that it breaks human cognition. How many stars exist in the universe? It's one of the oldest questions we've ever asked, and the answer? Well, the answer will change everything you think you know about scale, about numbers, and about your place in existence. But here's the problem. Your brain is lying to you. Walk into a room. Your brain instantly knows there are about 12 people there. Walk into a stadium and your brain tells you, a lot of people? 40,000? 70,000? You genuinely can't tell without counting. This isn't a failure of intelligence. It's how human cognition evolved. Our ancestors needed to assess immediate threats. How many predators are approaching? How many members are in that rival tribe? How many deer are in that herd? These numbers rarely exceeded a few dozen. We never developed the mental machinery to intuitively grasp thousands, let alone millions or billions. And that's where our journey hits its first obstacle. When someone tells you there are 7 billion people on Earth, you accept it intellectually, but you don't feel what 7 billion means. You can't visualize it the way you can visualize 7 people standing in front of you. And when we start talking about stars, we're dealing with numbers so fantastically large that they exist completely outside our intuitive understanding. So before we can answer how many stars exist, we need to build a framework. We need to feel the difference between a million, a billion, and a trillion. Without that foundation, the final answer will just be noise. Impressive noise, but meaningless. Let me show you what I mean. A million seconds is 11.5 days. You could count to a million in less than 2 weeks if you never stopped to sleep or eat. It's a marathon certainly, but it's conceivable. You can imagine devoting 11 days to a task. You've probably spent longer binge watching a TV series. A billion seconds is 32 years. If you started counting the moment you were born and never stopped, not for sleep, not for food, not for anything, you'd reach 1 billion in your early 30s. This single task would consume the entire span from infant to adult. What seemed like a big number with a million has become something that spans a human lifetime. Now here's where your brain starts to break. A trillion seconds is 31,700 years. To count that high, you'd need to have started before the invention of agriculture, before writing, before civilization itself. You'd have been counting when humans still lived in small nomadic bands during the last ice age. Every empire that ever rose and fell happened while you counted. Every war, every peace treaty, every technological innovation from the wheel to the smartphone occurred during your count. And you still wouldn't be finished. The difference between a million and a billion is 1,000 times. The difference between a billion and a trillion is another 1,000 times. These aren't just bigger numbers, they're different categories of magnitude entirely. And here's what I need you to understand before we go any further. When we talk about the number of stars in the universe, we're dealing with numbers that make a trillion look quaint. We're talking about hundreds of billions of trillions. Numbers so large that even the trillion comparison fails to convey their scale. Stay with me until the end of this video, because what you're about to discover will fundamentally change how you see the night sky. And if you want to explore more mind-bending cosmic mysteries like this, hit that subscribe button. It genuinely helps us create more content that makes the universe accessible. But we're getting ahead of ourselves. Before we can count the stars, we need to understand what we're actually looking at. Because for most of human history, we had absolutely no idea what stars really were. And that's where our story truly begins. Let's start with something you think you know, the night sky. On a truly clear night, far from city lights, you can see between 2,000 and 5,000 stars with your naked eye. The exact number depends on your location, your eyesight, and how long you let your eyes adjust to the darkness. Let's be generous and say 4,000 stars. That's it. 4,000 points of light scattered across the entire dome of the sky. For ancient humans, this was the entire universe. 4,000 stars. That's what philosophers and astronomers worked with for thousands of years. Every story, every myth, every attempt to understand the cosmos was based on those 4,000 visible lights. And here's what's remarkable, what almost nobody realizes when they look up at the night sky. Every single one of those visible stars is in our galaxy, not scattered throughout the universe, just in the Milky Way. In fact, the center heats up. Eventually, the temperature and pressure become extreme enough for nuclear fusion to begin. Hydrogen nuclei overcome their electrical repulsion and fuse, forming helium and releasing tremendous energy. A star is born. The Orion Nebula, visible as a fuzzy patch to your naked eye, is one of these stellar nurseries. It's only 1,300 light-years away, and it contains about 700 stars in various stages of formation. Some are still embedded in their gas clouds. Others are young stars less than 1 million years old, already shining with the light of thousands of suns. In the Milky Way, several new stars are born each year. That might seem small, but those stars will shine for millions or billions of years. Over the galaxy's lifetime, this steady trickle has built up our 200 billion stellar population. These stars come in a spectacular variety. Red dwarfs, as we discussed, are the most common, small stars that can shine for trillions of years. Yellow dwarf stars, like our Sun, make up about 7 to 8% of all stars. They live for roughly 10 billion years before dying. That's still about 14 billion trillion Sun-like stars in our galaxy alone. Then you have the massive stars, blue and white giants and supergiants, some over 100 times the Sun's mass. These are rare, perhaps 1% of all stars, but spectacularly bright. A single massive blue star can outshine 100,000 suns. They live fast and die young, exploding as supernovae after only a few million years. Every star type contributes to the total, from the faintest red dwarf that will outlive our Sun by a factor of 100, to the most massive blue supergiant that will explode in a cosmic firework display, to the dying red giants slowly shedding their outer layers into space. 200 billion individual nuclear furnaces, each with its own story, each at a different stage of stellar evolution. This is our galaxy, our cosmic home. 200 billion stars stretching across 100,000 light-years of space. But here's what will blow your mind. For most of human history, we didn't even know other galaxies existed. We thought the Milky Way was the entire universe. And we were so catastrophically wrong. In 1923, everything changed. Edwin Hubble, using the 100-inch Hooker telescope at Mount Wilson Observatory, pointed his instrument at a faint smudge in the sky called Andromeda. For centuries, astronomers had cataloged these fuzzy patches as nebulae, Latin for clouds. They assumed they were gas clouds within the Milky Way. Some were indeed gas clouds. But Andromeda was something far more extraordinary. Hubble found a special type of star called a Cepheid variable. These stars pulse in brightness with a predictable rhythm, and that rhythm directly relates to their actual luminosity. Measure the pulse, and you know how bright the star truly is. Compare that to how bright it appears from Earth, and you can calculate its distance. When Hubble did the calculation, he got a shocking result. Andromeda was roughly 2.5 million light-years away. It couldn't possibly be inside the Milky Way. It was an entirely separate galaxy, a whole other collection of hundreds of billions of stars existing far beyond our own. The universe, in that moment, became incomparably larger than anyone had imagined. Once astronomers knew what to look for, they found galaxies everywhere. Point a telescope at any patch of seemingly empty sky, and you'd find them. Dozens, hundreds, sometimes thousands of galaxies are in a single field of view. Then, in the 1990s, astronomers conducted an audacious experiment. They pointed the Hubble Space Telescope at a tiny patch of sky in the constellation Ursa Major. This patch appeared empty to the naked eye and even to most telescopes. It was so small it could be covered by a grain of sand held at arm's length. Hubble stared at this empty patch for 10 days straight, collecting every photon of light that reached it. The resulting image was called the Hubble Deep Field, and it was revolutionary. In that tiny, empty patch, Hubble found about 3,000 galaxies. 3,000 whole galaxies in a region of sky you could cover with a pinhead held at arm's length. Most were incredibly distant, billions of light years away. Their light had been traveling for most of the age of the universe to reach us. Do the math. If there are 3,000 galaxies in such a tiny region, and you need about 12 million such regions to cover the entire sky, that suggests tens of billions of galaxies in the observable universe. Later observations went deeper. The Hubble Ultra Deep Field found about 10,000 galaxies in an even smaller patch, and in 2016, astronomers analyzed all available data and arrived at a new estimate: about 2 trillion galaxies in the observable universe. But then, everything changed. In 1609, Galileo Galilei turned a primitive telescope skyward and discovered something that shook the astronomical community to its core. That Milky Band wasn't a cloud of glowing gas, it was stars. Countless individual stars, too faint for the naked eye, but clear through his lens. Every improvement in optics revealed more. Bigger lenses collected more light, showing fainter objects. Better manufacturing created clearer images. And the count kept climbing. Thousands became tens of thousands became millions. And then astronomers discovered something even more shocking. The stars. Can you see? They're almost entirely the rare bright ones, the cosmic celebrities. The massive blue giants, the luminous yellow stars like our sun, and the red supergiants. But these represent only a tiny fraction of what's actually out there. Most stars in our galaxy are red dwarfs, small, cool stars that burn their fuel incredibly slowly. They make up about 70 to 75% of all stars. And here's the kicker: none of them are visible to your naked eye, not a single one. Despite being the most common stellar type in existence, they're so faint that you need a telescope to see any of them. If you could see all the red dwarfs in our local region of the galaxy, the night sky would be packed with stars. Thousands of them are where you currently see dozens. The darkness between the bright stars would be filled with countless dim red points of light. This reveals something profound about the counting problem we're trying to solve. We can't trust our eyes. We can't trust our initial observations. Most of the universe is hidden from us, not because it's far away, but because it's simply too faint to see without technological help. So when we ask, how many stars exist, we're not asking about the 4,000 you can see. We're asking about everything: the bright and the dim, the nearby and the distant, the visible and the hidden. And that question is about to get much, much bigger. Because everything we've discussed so far, the 4,000 visible stars, the millions revealed by telescopes, even the hidden red dwarf population, all of it exists in just our neighborhood. Now it's time to count our entire galaxy, and the number is going to shock you. So how do you count something you can't fully see? This is the challenge astronomers face with the Milky Way. We're inside the thing we're trying to measure. Imagine being in the middle of a dense forest and trying to count all the trees. You can count nearby trees fairly easily, but distant ones are hidden behind the ones closer to you, and the forest extends in all directions beyond what you can see. Add to this problem the fact that dust clouds block our view in many directions. When you look toward the galactic center, you're peering through thousands of light years of cosmic dust. It's like trying to see through fog. The light from distant stars gets absorbed before reaching us. So astronomers got clever. They developed multiple methods that all point to the same answer. First, they count stars in small regions where they have good visibility, then multiply by the total area. It's like taking a census in one neighborhood, then extrapolating to the entire city. Second, they measure the total mass of the galaxy using gravitational effects. How fast stars orbit reveals how much mass must be present. Then they estimate what fraction of that mass is stars versus gas, dust, and dark matter. Third, They study other spiral galaxies similar to ours and use those as templates. All these methods have uncertainties, but they converge on a consistent range. The Milky Way contains between 150 billion and 250 billion stars. Most estimates cluster around 200 billion. 200 billion stars in our galaxy alone. Let that sink in for a moment. If you counted them at 1 per second, it would take over 6,000 years. You'd need to have started counting before the pyramids were built, before written language, before recorded history began. Think about what this means. You can see maybe 4,000 stars on the darkest night, but they're swimming in a sea of 200 billion stars you cannot see. For every star visible to your naked eye, there are 50 million invisible ones. The galaxy is incomprehensibly more populated than the night sky suggests. And these stars aren't static. They're being born constantly. Star formation happens in molecular clouds, vast regions of space filled with hydrogen gas and dust particles. These clouds are cold, typically just a few degrees above absolute zero. They're dark because dust blocks visible light, but inside them gravity is pulling gas together. When enough material gathers in one place, it collapses under its own weight. 2 trillion galaxies. Each one contains anywhere from a few billion to over a trillion stars. Dwarf galaxies with only a few billion stars. Spiral galaxies like the Milky Way with a few 100 billion. Giant elliptical galaxies with several trillion stars each. If we take a conservative average, say 100 billion stars per galaxy, the math becomes staggering. 2 trillion galaxies times 100 billion stars per galaxy equals 200 billion trillion stars. Written out, that's 200 trillion stars. In scientific notation, it's 2 times 10 to the 23rd power. Let me give you some perspective on this number. There are approximately 7.5 quintillion grains of sand on all of Earth's beaches. That's 7.5 billion trillion grains. For every grain of sand on every beach on our entire planet, there are about 27 stars in the observable universe. Pick up a handful of sand next time you're at the beach. You're holding perhaps a few thousand grains. For each one of those specks, there are dozens of stars scattered across the cosmos. Each star is a massive ball of nuclear fire, most likely surrounded by planets, existing in a galaxy somewhere in the observable universe. If every person currently alive started counting stars right now, and each person counted 1 star per second without stopping, it would take humanity nearly 800 years to count them all. Generations would be born and die during the count. Entire civilizations could rise and fall, and we'd still be counting. But here's what makes this even more extraordinary, and this is crucial, so stay with me. That number, 200 billion trillion stars in the observable universe, might be a dramatic undercount. Because everything we've discussed so far is only what we can see from Earth, and the universe doesn't end at our horizon. Now that you know the number, let's understand what it actually means. Because these aren't just points of light. Each one is a sphere of plasma, matter so hot that electrons are stripped from atoms, creating an ionized gas. This plasma is held together by the star's own gravity. And at the core, if the star is massive enough and hot enough, nuclear fusion occurs. Our Sun fuses hydrogen into helium in its core. Every second, about 600 million metric tons of hydrogen are converted to helium. In the process, about 4 million metric tons of mass are converted directly into energy following Einstein's equation, E equals mc squared. That energy works its way from the core to the surface over thousands of years before finally radiating into space as light and heat. The photon that hits your face on a sunny day was created in the Sun's core tens of thousands of years ago. The Sun has been doing this for 4.5 billion years and will continue for another 5 billion before exhausting its core hydrogen. This is just one star. One ball of plasma converts mass to energy through nuclear fusion, and there are 200 billion trillion of them. But not all stars are like the Sun. They come in a spectacular variety. Red dwarf stars are the most common, making up 70 to 75% of all stars. They're small, with masses between 8% and 50% of the Sun's mass, and they burn their fuel incredibly slowly. A red dwarf can shine for trillions of years. None that have ever formed have died yet because the universe isn't old enough. Every red dwarf ever born is still alive today. If 3/4 of 200 billion trillion stars are red dwarfs, that's about 150 billion trillion red dwarfs scattered across the cosmos. None visible to the naked eye from Earth, despite being the most numerous stellar type in existence. Yellow dwarf stars like our Sun make up about 7 to 8% of all stars. They live for roughly 10 billion years before dying. That's still about 14 billion trillion Sun-like stars in the observable universe, 14 billion trillion potential homes for life. Then you have the giants, massive blue and white supergiants, some over 100 times the Sun's mass. These are rare, perhaps 1% of all stars, but spectacularly bright. A single massive blue star can outshine 100,000 suns. They live fast and die young, exploding as supernovae after only a few million years. And most stars don't exist in isolation. Roughly half of all Sun-like stars exist in binary or multiple star systems, where two or more stars orbit each other, gravitationally bound for billions of years. That's 100 billion trillion binary systems, each one unique. Different masses, different orbital periods, different stages of evolution. When stars die, they leave behind remnants. Sun-like stars become white dwarfs, dense balls of carbon and oxygen about the size of Earth but containing half the Sun's mass. More massive stars explode as supernovae, leaving behind neutron stars, spheres just 12 miles across but so dense that a teaspoon would weigh about 900 billion kilograms. The most massive stars collapse into black holes, where gravity becomes so strong that not even light can escape. And here's where it gets truly personal. In the first few minutes after the Big Bang, the universe created only hydrogen, helium, and tiny amounts of lithium. 3 elements total. Everything else, every other element on the periodic table, was created inside stars. Carbon, nitrogen, oxygen, the elements essential for life, were forged in stellar cores through nuclear fusion. Iron and nickel were created in the final stages of massive stars' lives. The heaviest elements, gold, platinum, uranium, were synthesized in supernova explosions and neutron star collisions. Stars are element factories, and you are their product. Every atom in your body except hydrogen was created inside a star. The oxygen you breathe was forged in stellar cores billions of years ago. The calcium in your bones came from dying stars. The iron in your blood was synthesized in supernova explosions. You are quite literally made of processed stardust. This isn't poetic language, it's a chemical fact. But stars don't just make us, they make worlds. Until 1995, we knew of only one planetary system, ours. Then, astronomers found the first confirmed planet orbiting a sun-like star. Since then, discoveries have exploded. As of 2025, we've confirmed over 6,000 exoplanets, and the data reveals something remarkable. Planets are common, very common. Most stars have at least one planet. Many have multiple. Planetary systems appear to be the default outcome of star formation. If most of 200 billion trillion stars have planets, the number of planets likely exceeds the number of stars. There might be 300 billion trillion planets, maybe more. The universe isn't just filled with stars, it's filled with worlds. Based on data from the Kepler Space Telescope, roughly 20 to 50% of sun-like stars have at least one rocky planet in the habitable zone, the region where temperatures allow liquid water to exist. Being conservative, that's about 3 billion trillion potentially habitable planets. 3 million billion worlds where conditions might be right for life. Even if only a tiny fraction develops life, say 1 in a million, that's still 3 quadrillion living worlds. If 1 in a billion develops intelligent life capable of building civilizations, that's still 3 trillion technological societies scattered across the cosmos. And yet, we've found no evidence of other life. No radio signals, no megastructures, no obvious signs of industrial civilizations. The universe appears silent. This is the Fermi paradox, named after physicist Enrico Fermi's famous question. Where is everybody? With billions or trillions of potential habitats for life and 13.8 billion years for life to arise and evolve, we should see evidence of other civilizations. The fact that we don't is puzzling. Maybe life is extraordinarily rare. Maybe intelligence is the rare step. Maybe civilizations inevitably destroy themselves. Maybe they're hiding. Maybe the distances are simply too vast for contact. We don't know. But the sheer number of opportunities is what matters. With 200 billion trillion stars and hundreds of billions of trillions of planets, even extremely low probabilities could produce vast amounts of life through the law of large numbers. These aren't just numbers. These stars are connected to you personally. They made you, they surround you, and they might harbor countless other forms of life asking the same questions we're asking right now. You're standing on a planet orbiting one star among 200 billion trillion. Your sun is utterly typical, a yellow dwarf of average size and brightness. Your location is unremarkable, in the suburbs of a standard spiral galaxy in an ordinary part of the universe. From a cosmic perspective, you're insignificant. Your entire civilization has existed for perhaps 10,000 years. We've known about other galaxies for barely a century. In cosmic terms, we just got here. And yet we've measured the universe. We've counted the stars. We're tiny and brief, but we're also capable of comprehending the immensity that contains us. That capability is extraordinary. We're matter that has become conscious of itself. Atoms are arranged in such a way that they can ponder the nature of atoms. We are products of the universe that can understand the universe that created us. When you look up at the night sky, you're seeing photons that traveled for years from distant stars. Light that left Sirius 8.6 years ago. Light from Betelgeuse that departed 550 years ago during the Renaissance. Ancient photons completing journeys measured in centuries just to enter your eye and be absorbed by your retina, creating the sensation of seeing a star. You're connected across space and time to those distant suns. This perspective can be humbling. Your problems, whatever they are, occur in one small world among countless worlds. Your concerns are temporary and local. The universe doesn't notice your struggles. But this perspective can also be freeing. You don't carry cosmic significance on your shoulders. You're allowed to be small. You're allowed to have small joys and small sorrows. You don't need universal importance to matter. You matter to yourself and to those around you. And that's enough. But there's something else, something more profound. The observable universe, with its 200 billion trillion stars, might not be all that exists. It's simply the region of space from which light has had time to reach us since the Big Bang. The universe is 13.8 billion years old, but because space has been expanding while light travels, the edge of what we can see is about 46.5 billion light years in every direction. Beyond that horizon, there's more, possibly much more, perhaps infinitely more. If the universe is infinite, then the number of stars is also infinite. Not just very large, literally endless. There would be infinitely many galaxies, each containing billions or trillions of stars, stretching on forever in all directions. In an infinite universe, every possible configuration of matter would occur somewhere, and it would occur infinitely many times. There would be infinitely many galaxies identical to the Milky Way. Infinitely many planets are identical to Earth. Infinitely many versions of you reading these exact words right now. We don't know if the universe is actually infinite. We can't see beyond the observable universe, so we can't measure whether space continues indefinitely. Current cosmological models are consistent with either a finite but extremely large universe or an infinite one. The data doesn't yet distinguish between these possibilities. What we can say with confidence is that the observable universe contains approximately 200 billion trillion stars. Everything beyond that is speculation, though educated speculation based on our best understanding of cosmology. For now and for billions of years to come, stars will continue lighting up the cosmos. Each one is a nuclear furnace. Each one potentially hosts planets. Each one contributes to the ongoing chemical enrichment of the universe. Each one is part of the grand cosmic story of matter and energy evolving across billions of years. And we figured this out. From one small planet, we've measured distances to galaxies billions of light years away. We've calculated the contents of the observable universe. We've placed ourselves within this vast stellar population and grasped our connection to it. That intellectual achievement, measuring the universe from one tiny world, represents one of humanity's greatest accomplishments. We evolved on a planet where the farthest our ancestors could see was perhaps 20 or 30 miles to the horizon. Then, in just a few centuries, an eye blink in evolutionary time, we developed tools that extended our senses across billions of light years. We didn't just count nearby stars. We counted galaxies across the observable universe, estimated their stellar populations, and arrived at a number: 200 billion trillion stars. This is what makes us human, this capacity for wonder, this drive to understand, this refusal to accept the limits of our biology. We build telescopes and satellites and mathematical frameworks sophisticated enough to model cosmic evolution across 13.8 billion years. When you walk outside tonight and look up at the sky, remember what you now know. Those visible stars are the nearest few thousand of 200 billion trillion. Each point of light represents a massive ball of nuclear fire, most likely with planets, potentially with life, existing in a galaxy somewhere across the cosmic expanse. The light entering your eyes has traveled for years or centuries to reach you. You're connected across space and time to those distant suns. You're made of atoms they created. You're part of the same cosmic story that includes all 200 billion trillion stars. This knowledge should inspire wonder. The universe is vast beyond human scale. It contains more stars than grains of sand on our beaches. More stars than we could ever hope to visit. More stars than we can meaningfully imagine. Yet we've counted them. We've measured their distances. We've understood their natures. We're small and brief in cosmic terms, but we're also extraordinary. We're conscious matter that can contemplate the cosmos. We're the universe's way of knowing itself. And that's remarkable. That's beautiful. That's worth protecting and celebrating. If this journey through the cosmos has changed how you see the night sky, if you felt even a fraction of the wonder that drives astronomers to spend lifetimes studying distant stars, then do me a favor. Hit that subscribe button right now. Not for me, for yourself. Because there are more mysteries to explore, more cosmic questions to answer, more moments of profound realization waiting for you. Click that notification bell so you never miss when we dive into the next great question about our universe. And if this video made you think, made you feel something, made you see the world differently, share it with someone who needs to remember how magnificent existence truly is. Leave a comment telling me, after learning about 200 billion trillion stars, what's the one thing that blows your mind the most? Is it the number itself? The fact that we're made of stardust? The possibility of infinite universes? I read every comment, and your perspectives often inspire future videos. The cosmos awaits. 200 billion trillion stars shine across the observable universe, each one a testament to the grand processes of stellar birth, life, and death that have operated for nearly 14 billion years. You've spent this time with me exploring not just a number, but what that number means, where it comes from, and how it connects to your own existence. That's the real answer to how many stars exist, not just the count, but the understanding that comes with it. May you never look at the night sky the same way again. When you see those stars, remember 200 billion trillion of them. Each one is a sun. Each one is possibly the center of its own system of worlds. Each one is part of the grand cosmic story of matter and energy evolving across billions of years. We measured them. We counted them. We understood our place among them. That's what makes us human. That's what makes this moment in cosmic history special. We're here, we're conscious, and we've grasped the magnificent scale of the cosmos we inhabit. Thank you for joining me on this journey through the stars. Until next time, keep looking up, keep questioning, and keep wondering at the extraordinary universe we're privileged to call home.